Hi, today we're going to talk about shared ledgers. The concept, the paradigm of a shared ledger is becoming very popular at the moment. It's a ledger where banks can project their tokenized deposits and central banks can project their wholesale CBDC, and that single ledger can then be used to orchestrate transactions between those banks. So let's look at some of the practicalities of doing this. When you start with this as a design, as we have in a number of POCs, the first thing that confronts you as well, how do I implement privacy and permissions? And if you're looking at an out-of-the-box implementation of something like Hyperledger Besu, that's a little bit difficult because out of the box it doesn't come with this sort of segregation or partitioning between participants. And you definitely don't want to have Bank A being able to see Bank B's deposits or Bank B's balances at the central bank. So the easiest solution to this is to add a permissioning layer. So instead of having Bank A and other participants go directly to the ledger, they go through a permissioning layer which segregates out their requests so that it simply denies any request for something that they're not allowed to see. But if you think about it, a much better solution once you've introduced a permissioning layer is a standard SQL style database underneath. It makes no difference to your users. Their experience or their user experience is precisely the same, but you get a much faster, more robust and resilient solution underneath. And of course, this is what many of the more modern cloud-based accounting systems are doing, like Thought Machine, 10x, or Pismo. An alternative to that, instead of having this one big ledger with a permissioning layer, is to segregate out the blockchain so that each bank has their own blockchain ledger. And then you have a network that operates to orchestrate between them. So this is the approach that's taken sensibly by companies like Digital Assets and Corda, where the smart contracts are used to put in place constraints that, for example, keep Nostros and Vostros in line. Now, with those systems, there are, of course, a number of issues. One being that everybody has to have the same ledger in order for that to work, and secondly, really banks operate on their core banking platforms, and those core banking platforms do all of the complex things that banks need to do, like regulatory reporting, interfacing to users. And those are core banking platforms like Temenos or Oracle FlexCube. So you need to have that extra step that synchronizes between your DLT ledger and your core banking system. Now, the approach that we're taking at LedgerSwarm is to say, well, why don't we use those core banking platforms as integral to the network? So we have a network and smart contracts layer, and it operates directly onto those core banking platforms that and gives you the shared ledger paradigm, but directly from the ledger that is already implemented within the banking environment. Now, so LedgerSwarm works with existing platforms. It also works with DLT, blockchain, and other kinds of shared ledgers. It's fast, incredibly fast, secure, and scalable. And it has a reliable network and smart contract framework that operates on top of all of those different platforms. So what we've done today is really take you through this thought process that we went through when going from this idea of a shared ledger to something that's practically implementable and scalable within the world of banking. Let me know what you think and whether you go through the same thought process as we did.